From electromagnetic waves to unstable nuclear matter, radiation exists all around us from both man-made and naturally occurring sources. Humans are relatively unaffected by low-level radiation doses, but when that level rises and exposure time is increased, radiation may pose a threat not only to ourselves, but also to our environment. Hello, and welcome to Circuits from the Lab. I'm Harvey from the Systems Development Group, and today I'll be introducing a new radiation monitoring reference design, the CN0536. The EVAL CN0536 ARDZ is a low-power Geiger counter in an Arduino form factor. While it cannot distinguish between different types of ionizing radiation, its simplicity, low cost, and reliability makes it a compelling choice as a radiation monitor. Shown here are the circuit blocks that make up the CN0536 Geiger counter reference design. It uses a Geiger-Müller tube to sense the radiation particles. In operation, the anode of the Geiger-Müller tube must be held at a voltage between 280 to 500 volts. This high voltage generation on the CN0536 is created from a single 5-volt supply using a novel ultra-low power architecture. The primary stage is a non-synchronous boost converter controlled by a programmable precision oscillator, the LTC6906. A series of multiplier stages are cascaded in order to generate the 280 to 500 volt requirement. The overall current consumption of the CN0536 is minimized by controlling the power supplied to the oscillator using the LTC1540. When the voltage drops below the comparator threshold, the oscillator is powered up and the boost converter operates until the comparator trips off again. An onboard potentiometer can be used to adjust the Geiger tube's bias voltage. Now that the Geiger-Müller tube is properly powered, let's talk about how it senses radiation. When an ionizing particle enters the tube, a cascade of ion pairs is generated, causing an avalanche of additional electrons. This creates a momentary low impedance path between the anode and the cathode terminals, resulting in a small electrical pulse. With the use of the LTC1441, this Geiger pulse is amplitude shifted and time stretched so that it can be captured by a microcontroller. The CN0536 provides audio and visual indicators in the form of a buzzer and an LED, which are triggered when radiation events occur. Moreover, it also has 4 programmable LEDs that can be used according to the user's desired application. Now that we have a basic understanding of how the board works, let's move on to software support. The CN0536 comes with software support right out of the box with the ADI CUP 3029. There are a few example projects currently available, one for local monitoring and another over Wi-Fi to an MQTT server for remote applications. We will demonstrate both examples in our next video, so make sure to stay tuned. For more information, please visit analog.com/CN0536.